All right, so we're now recording. And we'll share the screen here. All right, so we're here, still 6.1. I should finish 6.1 today. In fact, I was only going to lecture with one more problem in 6.1. And notice the problems that I picked, a lot of them are from the homework. So every one that I do, that's sort of like one less that you have to do. And you'll get your first quiz today. It's due at 11:59. It's open everything. You can use your book, you can use your notes, you can talk to each other, you can consult the internet, and so on. But make sure you do it in your own writing and do it the way we did it in class. Okay, so don't make up your own idea. That's sort of how I can tell that, you did it in class or you just looked it up on the internet and the internet does it some other way. You have to do it the way we do it in class. And a reminder, add on problem 33 in the homework list. Okay, so I'm putting in problem 33 and I was going to end up showing you that problem anyway. Right, so that is that. Okay, and so I was going to sneak in a little bit of 6.2 also. Whenever I get the chance, I'd like to get a little bit ahead. Some of you have had me in the past, you know that's my usual strategy in case I fall behind a little bit later. Okay, somebody was wondering what's buffer day. Buffer day is not a holiday. Okay, I just put it there in case I fall behind, I get sick, my internet goes down. I think last year my internet was down a whole week, so I lost a whole week there. Okay, so don't treat it as a holiday. It's, I almost never keep this schedule the whole semester, right? Sometimes I get ahead, sometimes I fall behind, I get sick and I had to cancel or something else happens. So that's why I have buffer days. Okay. All right, first order of business is the quiz. Okay, so I'm going to show you the quiz. It's on the video, but maybe you want to get started on it. You might want to be ready to do a screenshot or get a picture on your cell phone. Okay, but you can always look at the video later. But I'll hold it there for maybe half a minute. Okay, so get your cell phone ready or be ready for a screenshot for the quiz. And some of you had me in the past, you're not doing it in groups or anything like that. Do it by yourself, but if you want to get a group, that's fine. If you want to work by yourself, that's fine. It's due at 11:59 tonight. So you have more than half a day. Okay, so here we go. Okay, so do a screenshot, take a picture on your cell phone or whatnot. Okay, sketch the region enclosed by the curves and find the area. So again, if you say, do I have to show up Friday? No, you can watch the video later, but if you wait until the video comes out, you just have a little bit less time. Okay, so I need a sketch. Okay, and not just a sketch, because you could easily just put it on your graphing calculator. There are graphing calculators now, right? And you can just put everything on a graphing calculator and do that, but I need you to show me some analysis of it. Okay, so y equals x squared, y equals 4x minus x squared. Now notice for number 2, they tell you to go from 0 to 2 pi. They don't tell you this. So you have to figure out what the limits are. Okay, so that's sort of like what we did yesterday. You should know what this looks like. You should know what this looks like. I'll give you a hint. This one has a minus, and that one's a plus, obviously, right? Okay, how do you find where graphs touch, right? So think back about that. What do I do to make that and that touch, i.e. equal? Okay, so once you find out where they touch, then you can figure out where to integrate from. Okay? And your sketch should also tell you which is the upper function and which is the lower function. Okay, I'm giving you all these hints, you guys. Okay, and then you integrate upper minus lower. You should all be familiar with that. And you should be somewhat familiar with that. So rough sketch, find out where do they touch, look at our examples yesterday, okay, and figure out how to integrate upper minus lower. Number 2, very similar. From trig, you should know what that looks like. This one might be a little bit harder, but it's 2 minus cosine x. Okay, well, you can think of how do you transform cosine into negative cosine and then add 2. Right? Or another thing you do is just make a little mini table. You got to go from 0 to 2 pi. So maybe plug in 0, pi over 2, pi, 3 pi over 2, 2 pi, and stuff like that. Okay.
I have a question, Professor.
So, yeah, you can go ahead, but I can hear you very faintly, unless you want to put it in the chat.
Oh, sorry. Can you hear me now? Can you hear me?
A little bit better, but go ahead.
I wondered if you wanted like explanations with words to know our thinking process during the sketching, or if you didn't really care about that.
You have to write it in words. No, you don't have to write it in words if you don't want to.
Okay.
You may, but yeah, it's not necessary.
Okay, thank you.
Okay. All right, you're welcome. Okay, let's see, attendance on quiz days. No, you don't have to, again, show up on quiz days. It just means you have a little bit less time to do the quiz, and I just lost the chat. I'll have to get it a little bit later, but yeah. Okay, so same thing, you know where you're integrating from, 0 to 2 pi, which is the upper function, which is the lower function, and then integrate. You might have to recall, how do I integrate cosine or negative cosine and all that kind of stuff. And that's basically it for that. Okay, so anybody want to ask a quick question about the quiz before I make it disappear? So you should already have it. Let's see. My system's asking me to reboot. I don't want to do it right now, so I'll have to snooze until later. Yeah. Okay, so let me stop share here for a moment and check the chat. Same thing, so you don't have to show up on attendance for quizzes. You can just watch the video later. Yeah. All right, that's the quiz. Make that disappear, and I'll go back in to share the screen and continue on. All right, so continuing on with this 6.1. This, I'm getting a message that my internet connection is unstable. Okay, if I ever disappear, which happened before, hang in there. I might try to take 5 or 10 minutes to reboot, but don't just disappear. If my computer ever goes down, that's happened before. Some of you had me before and saw that happen. I'll try to get back in. All right. Okay, problem 33. It seems like it ought to be easy, but it's actually one of the harder ones. Use calculus to find the area of the triangle with the given vertices. Okay. And let's see. In the quiz questions, there was something just like it that we did yesterday. Okay, use calculus to find the area of the triangle touching 0, 0, 3, 1, and 1, 2. Okay, so 0, 0, 3, 1, 1, 2. So how do I find the area of that triangle? Using calculus. There are ways to do it other than calculus, but this is a calculus class. Right? So what I need to do is find out the equation of these 3 lines. Okay, so recall if you're given 2 points, you find the equation of the line. Okay, these 2 are easy because they both go through the origin. So if I'm going to try to do y equals mx plus b, I already know that b is 0. So I just need the slopes. Okay, so 0, 0 to 1, 2, slope is 2. y2 minus y1 divided by x2 minus x1. 2 minus 0 divided by 1 minus 0, 2. So slope is 2. 2x plus b is 0. So this is y equals 2x. Likewise, this is y equals 1/3 x. From 0, 0 to 3, 1, m is 1 minus 0 divided by 3 minus 0, 1/3. So y equals mx plus b. I already know that b is 0. So this is y equals 1/3 x. The hardest of the 3 is this line, going from 1, 2 to 3, 1. So first I find the slope, y2 minus y1 divided by x2 minus x1. 2 minus 1 over 1 minus 3, that's negative a half. So the slope of this is negative a half. Then I do my point slope form, y minus y1 equals m times x minus x1. So y minus, I pick this point, y minus 2 equals negative a half x minus 1. Distribute, that's negative 1/2 x plus a half. Add 2 to both sides. 4 over 2 is 2. So y equals negative a half x plus 5 halves. So this equation is negative a half x plus 5 halves. And by the way, where you can double check that is both of these points should work. Let's try. If I plug in 1, negative a half times 1 is negative a half, plus 5 over 2 is 4 over 2, which is 2. And if I plug in 3, negative a half times 3 is negative 3 halves, plus 5 halves is 2 over 2, which is 1. So it definitely works. Okay, so I'm trying to find the area of this triangle I'm going to integrate from 0 to 3. And just like the problem that I did at the end of yesterday, it's upper minus lower, but you can see from here to here, and where's here? 1. The upper function is 2x. The lower function is 1/3 x. So to find this area right in here, I'm going to integrate from 0 to 1, it looks like, 2x minus 1/3 x. Okay, it's 0 to 1, 2x minus 1/3 x. And then the second part of the problem, I'm going to integrate from 1 to 3. Now the upper function is this funny thing, negative a half x plus 5/2, and the lower function is still 1/3 x. So the integral from 1 to 3 of negative a half x plus 5/2 over 1/3 x. Still using the principle of upper minus lower. Whatever the upper function is minus the lower. So there it is, 1 to 3, negative half x plus 5/2 minus 1/3 x. Okay. So one more time, from 0 to 1, upper is 2x. The bottom is still 1/3 x. Then the upper function from 1 to 3 switches to being this thing, negative a half x plus 5/2 minus 1/3 x. Okay, so I have these two integrals. I don't like the fractions. Okay, so in red, if you can kind of see the red, okay, I like to make this nice. So I multiply by 3 inside and 1/3 outside. Now you say, do I have to do that? No, you don't have to do that, but it means you're stuck with all these fractions. Okay. Here I see all these fractions, 2, 2, 3. I decided to multiply by 6 inside and 1/6 outside just to clear the fractions. Again, do I have to do it? No, you don't have to do it, but I'd rather not have fractions. I mean, wouldn't you rather integrate stuff like that than have the 2 there and the 3 there, right? I think this is much better. Your internet connection is unstable. Uh-oh. Okay, so don't be surprised if I disappear. If that happens, give me 10, 15 minutes to get back on or whatever. Okay, so I distributed 3, that's 6x minus x, right? 3 times 2x is 6x. 3 times 1/3 is 1, so 6x minus x is 5x. And there's a 1/3 in front. And this is going to be 6 times that is negative 3x. 6 times 5 over 2 is 15. 6 times negative 1/3 is minus 2x. So that comes out to be 15 minus 5x. See, this looks a lot better. This looks a lot better. Yeah, there's a 1/3, there's a 1/6, but at least I save it until later. Okay, so 1/3, 5x squared over 2 from 0 to 1. 1/6, 15x minus 5x squared over 2 from 1 to 3. Okay, this is going to be 5 over 6. Okay, you can tell when you plug in 0, you get 0, right? Plug in 0, that's gone. So I just plug in 1, it's 5 over 6. So that's easy. This one's a little bit harder. So I got the 1/6. So let's see, plug in 3. 15 times 3 is 45. Plug in 3 here. 5 times 9 over 2. So 45 over 2. Minus parentheses. Now I plug in 1. 15 minus 5 over 2. Okay, so I have 5 over 6 plus 1/6. So let's see, what did I do here? 45 minus 15 is 30. Negative 45 over 2 minus a minus, so plus 5 over 2. These two, negative 45 over 2 plus 5 over 2 is a minus 40 over 2. Negative 20. So that's going to be 5 over 6 plus 10 over 6, which is 15 over 6. Final answer is 5 over 2. All right. So yeah, that was one of the harder problems, as you can imagine there. Okay, so folks, I'm now officially, not even quite 8:30, I'm officially done with what I was going to lecture on 6.1. You were responsible for this, put in 33, but guess what? We already did 33. Okay. So you're responsible for all this. I already did a whole bunch of them, right? So remember, you have a 70% homework requirement. That's really a joke because I end up doing 25%, 30%, 40% of the homework. So it's not that hard to do the rest of the problems. And I try to show you at least one of each type of separate problem. And your quiz is hopefully somewhat similar. Okay. And again, you say, when do I turn the homework in? Only on test day. So 6.1 to 6.5, you turn all of that in Friday, 9/3. Okay. It's due half an hour after the test ends. I give you a little bit more time. But if you want to turn it in early, you may. Okay. I'll always take the homework early. So everything you turn into me, just get your cell phone out, right? Click, 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 or scan it and email me, homm@smccd.edu, right? I don't do anything on Canvas. You're saying, I look on Canvas, I don't see anything for assignments module. I don't do anything on Canvas except give you the Canvas announcements. Okay, so starting next week, I won't be sending you emails in general because I wanted to catch everybody that's still trying to add to class. We've pretty much settled down to who's going to be in the class and who's not. So starting next week, most of the time, I'll send you Canvas announcements for these videos and other announcements, but don't completely forget about your SMCCD account. I'll email you from time to time from that. Maybe Canvas is down for some reason, but most of the time I would send you Canvas announcements, but that's all I do on Canvas. Don't look for Canvas discussions or modules or assignments. No, you've already got all the calendar. You've already got all the homework, right? And there's that. Okay, so that's that. I'm going to sneak in a little bit of 6.2. And then I'm going to let you ask questions if you have any, and you may even ask me stuff about the quiz. Okay, so I'm getting a little bit ahead. 6.2 and 6.3 are on volumes, something called volumes of a solid of revolution. And I've got that over here, volume of a solid of revolution. So 6.2 and 6.3 both talk about volume of a solid of revolution. You say, what do you mean by that? Okay. So introduction, 6.2 is something called the disk method, D-I-S-K, disk method. Okay, so a little bit of review of simple geometry formulas. Maybe you had this in middle school. If I have a right circular cylinder, like a can, has a radius and a height, you might recall the volume is pi r squared h for a cylinder. It was the cross-sectional area times the height. So what's the area of a circle? Pi r squared. And you multiply it by the height. So volume is pi r squared h. Okay. By the way, if you want to put that on your cheat sheet, you may. But many of you already have it memorized. But I'm going to show you exactly what you need in particular. All right, so for a disk, imagine a very, very tiny disk. Okay. Well, even though if I have a disk like that, it's not very high up. It still looks like a cylinder, right? It qualifies as a cylinder. So it fits the category of volume equals pi r squared h. Right. So now a little bit of theory. I'm going to show you something on page 441, figure 6. I've got this region here. It looks like y equals square root of x from 0 to 1. Okay, I'm not finding its area right now. Imagine you were to take this region and spin it about the x-axis. Spin it around. I can't draw. I'm not an artist. Some of you can draw this way better than me, but it would end up looking something like this, right? It's kind of like a sideways bowl, right? If you turn it like that, you say, oh, it kind of looks like a bowl, right? So we're taking some region and revolving it about some axis. So that's why we say volume of a solid of revolution. We take some two-dimensional figure, we spin it about some axis, we get a three-dimensional shape, right? And we're trying to find a volume of that shape. Seems pretty complicated, but if you break it down, its analysis, it's actually not that bad. Okay, here's a slice, a typical slice. Maybe you did this at the end of Calc 1. imagine taking this particular slice. There's actually a whole bunch of slices. Okay, so imagine chopping up the interval from 0 to 1 into a whole bunch of these. This is just a typical one. So if you imagine something like this, okay, they chopped it up into 10 pieces, 20 pieces, and so on, right? It does say disk on the bottom, and I'll show you why later. So if I take just this slice and spin it around, I get something that looks like this, right? And what is this? It's a disk. It looks exactly like this, except turned 90 degrees. And I guess if I could turn my picture 90 degrees, there it is, right? It's a disk. Now you might say, well, it's not really a disk because it's slightly curved here. You're right. It's a little bit curved, but for continuous functions, if delta x is very, very small, this function doesn't get a chance to change that much, right? And the smaller delta x is, the smaller my delta x, the more and more it looks like a true disk. I.e., the language we would say is in the limit as delta x approaches 0 and n approaches infinity. In case you're wondering, you don't have to write any of this down. I'm just telling you the theory. So my typical slice would look like this. So what am I integrating? A disk, which has a formula, pi r squared h. So what qualifies as the h here? Well, that h is not very big. It's delta x, right? In fact, I turn it 90 degrees like this, then that kind of looks like my picture right over here. Oh yeah, the height is delta x. And there's my circle, pi r squared. Okay. So the little change in volume right here is like a pi r squared h or pi r squared delta x. And that's going to be true for all of them. So if I have a picture like this, where it's chopped up into 5 disk, 10 disks, 20 disks, right? See, it doesn't look smooth, but if n approaches infinity, the number of pieces that I chop it up into, which means delta x approaches 0, it looks more and more like what you want, which is like this. Right, so in the limit, which means we let n go to infinity, delta x approach 0. In the limit, delta x becomes dx, and you integrate pi r squared. Okay. Now, you might be puzzled and all this. I have no idea what you're talking about. It's okay. Here's the bottom line. So maybe put this on your cheat sheet. For the disk method, you're integrating pi r squared, essentially. What's the radius? You integrate pi r squared. And pi is a constant, 3.14, blah, 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 blah. You normally can just factor that out. So you take out the pi, you normally integrate r squared. So if you didn't understand any of the theory, just be able to plug into the formula. For volume of a solid revolution using the disk method, you're basically integrating pi r squared. Okay. So I would say put this on your cheat sheet. Remember, you're allowed to have one formula sheet. Okay. Reminder again for before the first exam, send me a photo ID of yourself. Again, for a class like this, I don't get to know what you all look like, right? So how do I know you're actually taking the test? So please show me your driver license, photo ID, something like that. You can block out, any sensitive information. I just need your name and your picture. So take out, your age, your weight, your height, your address, and all that sensitive information. I just need a picture with you and your name on it. Okay. So you might be spinning this way, but a caution, again, you might have x as a function of y, you might be spinning the other way also. Okay, so this is the bottom of 441. So there you've got a delta y, it looks like. Okay, tiny change in y, spinning about the y-axis perhaps. Right, so I'll show you one example. Maybe that's all I was going to show you, since I'm already technically a little bit ahead. Okay, so the example I'm going to show you actually isn't in our book. Or at least it shows you the idea. I put 1 star here, which means it was problem 1 in the previous edition, but not in our edition. Okay, so it says take the region bounded by y equals 2 minus a half x, y equals 0, which is the same thing as the x-axis, x equals 1, x equals 2, and spin it about the x-axis. Okay, so y equals 2 minus a half x. That's a line. Y equals 0, same as x-axis, x equals 1, x equals 2. So I take this region, happens to be called a trapezoid. You guys remember what's a trapezoid? Has 4 sides. One pair of opposite sides is parallel, but the other isn't. Okay, take this thing and spin it about the x-axis. Can you imagine spinning that around? You get some funny shape. We're trying to find its volume. So all I do is integrate pi r squared. So the trickiest thing here is to indicate what's the r. Now, this first example is pretty easy to find the r, but later on it might be a little bit more difficult. So I take this thing and spin it around the x-axis. The radius is just this. That's what we normally call y. So what I have here is r. If you can't read that, sorry, that's r is the same as y, which is 2 minus a half x. Technically, you could argue, well, the r is different, yeah, because this radius is a little bit bigger than this radius, right? The leftmost height and the rightmost height are slightly different. Ah, yes, but if delta x is really, 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 really small, let it approach 0, right? Then for continuous functions, the graph doesn't have that much of a chance to change. Okay? So in the limit, it's okay to just say the radius in this case is y. So bottom line, I'm integrating pi r squared. So integrate from 1 to 2, pi r squared in this case is y squared. So I just put 2 minus a half x. By the way, don't literally put the letter y because I'm integrating with respect to x. You don't have the letter y, you put y is equal to, which is 2 minus a half x squared. Okay, then I just factor out the pi, and that looks like a minus b squared. Quick reminder, right? A plus or minus b squared. A plus b squared was a squared plus 2ab plus b squared. A minus b squared was a squared minus 2ab plus b squared. You should all know that from algebra 1, right? But again, if you wish, you really should have it memorized by now, but you can sneak that on your cheat sheet if you wish. Okay, so pi normally comes outside. A squared, 2 squared is 4, minus 2ab, 2 times 2 is 4, times a half is back to 2, so 2x, plus b squared, half x squared is 1/4 x squared. Okay, the writing's a little bit small, so I'm gonna have to raise this up. Can I get this thing bigger? I guess not. All right, so pi is outside. Integral of 4 is 4x. Integral of 2x is x squared or minus x. So if I just do the power root, negative 2x, right? That's negative 2x to the 1. So negative 2x squared over 2, the 2's cancel out. So I have that. And then 1/4 power root x cubed over 3 from 1 to 2. Remember, you can always double check by differentiation. Right? What's the derivative of that? 4. What's the derivative of negative x squared? Negative 2x. Okay, this might be a little bit trickier because of that, but it's actually better not to multiply it out. If I just leave it like that, if I take the derivative, 3 will cancel that 3, right? 3 cancels that, so I have 1/4 x squared. So it's perfect. Okay, so leave the pi alone. Plug in 2, 4 times 2 is 8. Minus 2 squared is 4. Your connection is unstable. Oh, I'm getting that message again. See if I can get through at least today. See, plug in 2. 2 cubed is 8, right? And 8 divided by 4 is 2, so 2/3. See if I can finish class before I get bumped out. Okay, plug in 1. 4 minus 1 plus 1, 12. Okay, the rest is arithmetic. Okay, see the thing I have in red? They all cross out because it's 8 minus 4 minus 4, right? 8 minus 4 is 4, minus 4 is 0. So I just have left 2/3 plus 1 minus 1/12. Common denominator is 12, so there's a pi. 2/3 multiplied by 4/4, 8/12, plus 1, which is 12/12, minus 1. So that comes out to be 19 pi/12. Sorry if you can't read that. That's 19 pi/12. I'm afraid to write anything because if I write it, I'll just mess it up more. But this is 19 pi/12. Okay. All right, so that's what's happening. So let me go ahead and show you the problems that are in the book. For those of you who don't have the book and weren't planning on getting it. Okay, so 6.2 assignment. I'm basically done, folks. So I'm going to let you ask questions, and if not, we'll just stop, let you work on the quiz, due at 11:59 tonight. So 1 to 29 odd. So page 446. So some of the problems there. You don't try to copy all this down, watch the video later for those of you who aren't getting the book. You may have to go up to 29. So there is 29 right over there. Okay, all right. So Monday, I'll start showing you more of these. So it looks like you're revolving about the x-axis sometimes about the y-axis. And then what gets trickier is about some other line. Like what happens if I try to spin it about y equals 1, right? Or x equals 2, or whatnot. So how do I find volumes in those circumstances? And I guess the problem's at the end, it looks like they give you some picture, and you have to take the particular picture and rotate it about one of the lines, right? So region 1, spin it about OA. That's just about the x-axis, but maybe spin about AB, right? That's way over here. So what happens if I try to go like that, and so forth? Okay. So that's what's happening there. All right, I'm done, folks. It's 8:45. So you may ask me questions now. If not, we're done. Have a good weekend. I'll let you work on the quiz. So let me stop the share temporarily and check the chat. Okay, schedule-wise, I'm right on par. In fact, I'm a little bit ahead. Right, because on the schedule, I already did that, but on the schedule, it was only supposed to finish 6.1, and I snuck in a little bit of 6.2, which was scheduled to be on Monday. Okay, and I think I've caught up with the chat there. So you've got your work for the quiz. You can talk about it, help each other out. Take a picture on your cell phone, just click, 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 and email it to me. If you have a scanner, go ahead and scan it. Show all your work on the quiz. I've already given you hints on what to do for the quiz too. All right, so any other questions, please? Otherwise, we're done for the day. Wait just a moment. All right, have a good weekend. We are done. Quiz due at 11:59. Okay, all right. Have a good day. Have a good weekend, everyone.
Thank you, Professor.
Thank you.
Thank you, Professor.
Thank you. Have a good day.